All right, so last time we stopped at, last time we did mitigation analysis using flood barriers, and I showed you guys how we do a flood barrier. Basically, we make an if statement. If the flood depths exceeded the barrier height, so the barrier is useless and you will use the loss function. But if the flood depth is less than the barrier height, so the flood loss will be zero. So it's either a zero or either the total amount of loss. And then I introduced how we do mitigation analysis using bumps, and we are modeling bumps as a tool that can decrease the flood duration. And we are investigating a number of flood durations, and I showed you that we have from D1 to D5, and each one represent the number of days that flood will stay in place. Like, for example, D1 is flood will be like for 1 day. D2 will be 2 days, 4 days, 6 days, or 10 days, okay? So we have all of these in place, and we need to investigate the impact of flood duration on the amount of flood loss reduction. So that's the purpose of this part of the code. And not only this, we are also investigating if not only the whole population is gonna use pumping to decrease the flood duration. So I showed you how you select a random population or a random samples of the buildings in the floodplain. So basically, I showed you how to do uniform distribution and pick 10% of the impacted buildings randomly from the floodplain. So I showed you that last time. And then we here, like in this code, we are doing 1D interpolation from the 3D flood surface so that we can get the amount of losses. So all of this it's in the recording that we have from last time. But today I also want to show you something like so that you can visualize what happens when we investigate the flood duration. So I wrote a code that can visualize the 3D flood loss surface at different flood duration. So actually, just like to do some plots, I wrote like 600 lines in MATLAB. Let's see what these 600 lines are getting us in MATLAB. So this is, do you guys know what is that? Does any of you remember what is this? This is, yeah, the flood loss surface, right? So this is the flood loss surface that shows you how much a flood loss that you are gonna have at each specific flood depth and flood duration. So here's, for example, I have from flood depths from 0 to 7 and flood duration from 0 to 300 hours. And what I did here, I took some sections in this surface to shows you how the flood loss is gonna change with the flood duration. Like, for example, if you have 20 hours flood duration, so this will be your flood loss. This will be the flood loss line. And if you have 48 hours, it will be this. If you will have like 150 or 200 or 240. So each one of these loss represent the amount of losses at a specific time. And as the flood duration is getting increased, the amount of losses that we are expecting is getting increased. So this is basically like here, if you see, like, if I took all these out as a lines, let me pick another. Yeah, this one. So this is the flood loss surfaces. Like if you look, at each one of these, like the trend of these curves is getting more as the flood duration is getting more. So each one of these at a specific flood depth, like let's say, same building archetype, same thing, both of them got a flood depth, for example, 2.8 meter. If the flood duration stayed 1 day, it will be a specific flood loss. 2 days, it will be much more loss. And 6 days, 8 days, 10 days, each one of them is gonna give you much more loss. But if we give it another look here at the lowest flood duration, like if the flood duration is like 1 or 2 days, there is a significant like decrease in the amount of losses. But if the flood depth is from 6, 8, 10 days, the amount of losses will be much more. Can you see the trend? Like the surface Here is very, very low, and then like it going up sharp and then it going smooth. So here the flood loss reduction will be minimal, like 6 days. From 8 days, it's not that big deal. Like it's, but here from 2 days, from 1 day to 2 days, there is a sharp increasing and then a smooth increasing, smooth until you get to the 10 days. So what I'm doing, rather than interpolating from a 3D surface and doing 2D interpolation, so I'm doing 1D interpolation by picking the data at just the 24 hours. So that's what I'm doing in my MATLAB code, picking the data at D1. So this is D1, D2, D3, D4, D5. So going back to my MATLAB code, if you see, let's get back here. You'll find that I'm getting the losses from D1, assuming that the flood duration is gonna stay for 24 hours for 20% of the buildings in the floodplain that are selected randomly from the whole population of buildings that are flooded. And I'm doing interpolation 1, like interpolation 1D. And I'm taking the flood loss surface. So I'm defining the XY of the loss surface. So here's the depths. And I'm only doing the interpolation on the on D1. Like I'm asking, rather than picking the whole 3D surface, just I'm gonna do it 2D. I'm gonna do it 2D and the 2D XY, because for 2D, MATLAB needs XY. So my X is that's values. My Y is the values on the surface is specifically at D1, all these values. So exclude all the values except the values here on this curve. So this is what this function is doing. This one. F3D loss, the 3D loss surface, pick all the X values, and the Y values, I only need the D1. I'm not interested in any other values rather than D1, and pick the 3D surface that for building archetype number I, like if it's building I, so it's archetype I, like I could be building archetype 1, 2, 3, whatever. And since this is archetype 1 and 3, so use the verse floor elevation measured from the ground for this building archetype. And once you are done, convert the loss ratio into loss value by multiplying the losses by the building replacement cost. If the building is a $1 million and the losses is 20%, so we are losing 200K. Okay, and then I'm doing if statement. So I'm doing if statement because I have archetype 1 and 3, and then I'm saying else if the building archetype is not 1 and 3, do the same thing except to measure the flood depth from the verse to floor elevation. Okay. And then the next step, as I told you last time, we are calculating flood losses at the building level. So right now, I'm not interested how much the building losses is. I'm interested in how much is the flood loss reduction at each building. So we need to subtract the flood loss with mitigation using bumps to decrease flood water duration. And we have a base flood loss scenario without bumps. So if I subtract the losses that comes from the two scenarios, without mitigation, minus mitigation, I will get how much loss reduction I'm having with using bumps to decrease flood duration. This for each building, like for building number I, and then it will be a vector. Each row represent a building. And then I'm interested how much losses I'm reducing at the community level. So I'm doing another matrix or another element to calculate how much loss reduction at the community level by summing the loss reductions from all the building. Like for example, if I have 100 building, I see from building 1 I'm saving 100K, from building 2 50K, 20K, 10K. I sum all of these and put them on only one a vector, like it has a size of 1 that has one number. Okay, and I do this for all the flood duration scenarios. Like I have flood duration 24 hours, which is 1 day, 2 days, 4 days, 8 days, and 10 days. And I'm doing this for all the selected random samples from all the buildings. Like, do you guys remember S20? What S20 mean from last time? And I have after this S30 and S40. S20, we make this name so that we don't get confused. So we made D1 to represent the duration scenario number 1, 2, 3, 5. And if you guys remember from last time, we have like something that has HP, HP1, HP2. Do you guys remember? HP1, HP2 is a barrier height scenario. Barrier height scenario 0.2, 0.4, 0.8. So we call them HP, and we put a number based on the scenario. S means the shapefile that I'm taking the data from. This is S. And if S has 10, I mean like I'm only selecting 10% of the impacted building. If it's S20, I'm only selected 20% of the building. This is what we did last time, if you guys remember. You guys remember when we selected random buildings? Like I selected here 20%, and I have 592 buildings, and then I export them, and I do the same thing with 30, 40%, 50%, 60%. So S means the percentage of the buildings that you are going to apply these mitigation measures to. Okay, so I will just want to show you some graphs. So this is just on the side. We are not going to do fragilities with mitigation because it will complicate your project. But for project, we're only interested in dollar values of loss reduction. So I'm not interested to tell me that I have 100 buildings that were damage state 4. With this mitigation actions, they become damage state 3. Okay, so we are going to focus only on losses. So we will disregard the flood fragility curves when we do mitigation. Okay, so doing mitigation, we will focus on the loss surface and loss curves so that we can get dollar value or how much loss reductions that we have. But I'm going to show you the fragilities in 3D if you take them at different flood durations. So look at these fragilities. This one, all right, this one, let me rotate this so that you can see. So this actually shows, yeah, it shows 4 fragility curves, but actually I'm not sure if you guys can see, this is 2 on top of each other, and I have 1 here and 1 here. If I rotate this way, you will find the 4. So this is 1, 2, 3, 4 fragilities. If I take sections here, section 1, 2, 3, at each flood duration, you will come up with a fragility set at each flood duration. Let's look at them. Yeah, they are here. So this is the fragility set at each flood duration. So basically, I can do same thing with fragility, but we are not going to do it for the project. I'm just going to show you how's the flood fragility will look like. So you have these at flood duration 1 day, 2 days, 4 days, 8 days, and 10 days. How does it look like? Basically, you cannot see damage state for this red line in these 2 fragility, which means that the building is not gonna reach damage state 4 with 2 days flood duration, because damage state 4 is a structural damage. But assuming that the building is soaked in water for like 6 days, so right now the foundation is gonna have some scour, you will have some serious structural damage, and then damage state 4 is gonna show up, the red one. This one, and with flood duration is getting increased, so the exceedance probability of damage state 4 is gonna get increased. So this is what the 3D how's the 3D fragilities look like. If you want to look at them separately, so here this is these fragilities like damage state 0, 1, 2, 3, at flood duration 1 day, and this is 2 days, and this is 3 days, sorry, 6 days, I believe, or 4 days. And the last one will be 10 days. This is how the fragilities look like. So I was just showing you how the fragility with duration is gonna change. If you want to know more information, you can read one of the publications that I had in the Google Drive of the project. So you will find more details about these fragilities and how the flood duration impacts the damage states that the building can be at the same flood depths. Does anyone of you have any question on modeling the impact of flood duration on buildings? Okay. All right, so once you are done with doing this for 10% of the buildings, like this one. So right now, I modeled that 10% of the buildings in the floodplain that are selected randomly are using bumps to decrease the flood duration for 5 scenarios, D1 to D5. What if 20% of the building is gonna do this? First, you need to create a shapefile of the 20% of the buildings. And I showed you how to do this. And you will copy this code, Control-C, and you will go to a blank page in MATLAB, and you will just swap S10, Control-C, and then you will make Control-F, find and replace. You will find in any line of these codes, if you find S10, replace it with S20, and then replace all. So you'll find that all of these lines has been replaced from S10 to S20. So you can run the same thing without writing the same code one more time and doing the same thing for 20% of the buildings. And then you can do it for the 30, 40, 50% of the buildings. All right. And you will see that I did that here. So you'll find the next one. Like once I'm done here, I can Control-A to select all of these and then Control-C, and then you can paste them here. You see all these are S20, and then you can do the same thing, S30, and then the next one 40, 50, 60, 70, up to 100% of the buildings are applying flood barriers. Like this one, S100 means the shapefile that has 100% of the buildings applying water pumps to decrease flood duration. Okay, so what is the next mitigation measure? So just if you are gonna watch this on YouTube or the recording for this class, that is not needed. I was just like doing this code for one of the reviewers. So this part of the code is not needed. So until here, yeah, I'm gonna start here from this one. This one, I'm gonna investigating what is the impact of using flood barriers and elevating water sensitive components. Let's assume that you know that there is a flooding is coming. So you are taking 2 precautions to protect your assets in your building. So you were able to build a flood barrier, and in the same time, you were able to elevate the water sensitive components, your computer, your TV, your gadgets, any of the appliances that are handy and you can elevate them. So we were able to elevate a bunch of components, and I showed you how I selected these components. I only did that for residential buildings, the first 4 archetypes, and I only investigated the impact of elevating these components. What if these components were in this elevation? What if we increase them to another elevation? How this will impact the amount of flood losses. Also, let me show you a code that I developed to show you the impact of elevating water sensitive components. Let me run this code very quick. I'm just doing some plots to show you how elevating water sensitive components are gonna change the amount of losses. Okay, so this is an example for one of the archetypes. I believe it's archetype 2, one-story residential building on a slab on grade. The blue curve shows the loss curve for this building without elevating water-sensitive components. And the red curve shows what if you elevated the water-sensitive components. You will see that there is a little or a small difference between these two. However, it adds up when you do it at the community level. So, like, for example, if the flood depths is like very like low, like 0.5 meter or so you'll have like 5% flood loss reduction if you did that. But if the flood depth is like 1.4 meter, you will have about like 10% flood loss reduction, which is very good. So it varies, depends on the flood depths. However, if you elevated the water sensitive component, but you got a flood depth of more than 3 meters, so the new elevation of the component will be useless. Why? Because, all right, I have a one-story building. I was able to elevate my water sensitive component to the attic, like up there or in the second story. But if the water reaches the second story, so they will get wet anyway, right? So elevating my water sensitive component, all the flood loss reduction will tend to be 0. Okay, so this is how it's described. Yeah, the difference is very small, and then they get optimal at some point. And then as the flood depth is getting increased in your building, it will turn out to be 0. This is if we are looking at a 2D function. Let's see how it will look like in a 3D function. Yeah, okay. So this is the 3D flood loss surface. Actually, you will feel like it's the same surface that you were looking at. But if I rotate this, oh yeah, it's the same one. I think I have a one that has, okay, let me rotate one. Oh, you're right here. Yeah, it's different. So can you see? It's the two surfaces on top of each other. Can you guys see it? This one and this one. The first one is the with mitigation or without mitigation? This one. Without mitigation, because if I did mitigation, it should be the one goes down. And I took sections at different flood durations. So this is, for example, what if you were able to use pumps and also were able to elevate the water sensitive components? How this is gonna impact the amount of loss reduction that you have. And let me show you the 2D curves at each one. So here, okay, this is 2D. Yeah, this one. Okay, so here you will find at this flood duration you can save, but at some duration the difference between these two curves is getting less. But it's still it's kind of saving of losses that you can save at the building level, and it adds up at the community level. Okay, so it worth investigation. All right, but looking at all of these, there's a bunch of numbers of mitigation measures that we can apply. What if we are looking at elevating flood barriers with decreasing flood duration for all of these? What if we use the flood barriers and use pumps and also elevating water sensitive components? So there is lots of them. So what I did in this publication, and I want you to do it for this project, is to investigate a number of these, not all of them. So maybe, okay, let's see what options that we are having here. So I can do flood barriers, right? And I showed you how to do it last time. And I can do pumps to decrease the water duration. And I showed you the scenarios. So we can have HP 1.2 meter until HP 1.1 meter, right? And I told you last time, it's more wise to do flood barriers like 0.5, 1.5, or 0.5, 0.7, 5, and 1.25. So you can start from 0.5 meter if you want. But if you want to do this, do that. And flood duration, I start D1 is 10 days, D2 8 days, until D5 is 1 day. Okay, so we did this separately last time, and I continue today on that. What if we want to investigate pumps and elevated water sensitive components? That means that we want to see if the flood duration is 10 days and I'm elevating the water sensitive component, how much flood loss I'm gonna have. And the second one will be, what if it's 8 days and I'm elevating components, and 6 days, 2 days, and 1 day, right? So this is one way to do it. Same thing with flood barriers. What if I use the flood barriers with elevating water sensitive components? E3 means like mitigation scenario number 3, elevating water sensitive component. This is what does it mean by E3. So I elevate component with flood duration equal to 10 days, and I keep doing that until 1 day. I do the same thing with the flood barrier. Elevated components with flood barrier 0.2 meter, 0.4, 0.6, 0.8 until 1 meter, right? Is that clear? This is very simple. You know what you will do? You will just replace the flood fragilities for the original buildings with the flood fragilities with the mitigated building with elevated components. And I give you both sets. I give you a set of fragility for buildings without mitigation and a set of fragility with building with mitigation. Okay, let's get back to the code and show you how to do it. If you look at the data that I gave to you in the Google Drive, you will find that you will have 4 archetypes, has 2 Excel sheets. One of them F1 3D fragility, one of them is F1 3D elevated. So all what we are gonna do for these scenarios, we are gonna do the same thing that we did last time, except that we are gonna replace the fragility with word elevated. So here, coming here, I'm calculating losses for flood duration scenario D1, but with elevated component. EC means elevated component. And I'm gonna do the same thing. I'm gonna apply this for 10% of the building, 20%, 30%, up to 100%. And let's see what I have here. I'm having the same thing. I'm doing a for loop to go building by building over the 10% of the selected buildings. And I'm doing it for building 1 and 3 only because this calculates the flood loss measured from the ground elevation. And I'm using the same code, except I'm using the 3D loss surface for elevated components. Like it has AC. Let's check what we have up there. We were interpolating F3D loss without elevating component. If you guys remember like 3 lectures before, we created 2 3D metrics of the loss surface, one with elevated components and one without elevating components. I mean, like one with mitigation, one without mitigation. What we are gonna do right now, we are gonna do the same thing that we did in the last lecture, but with the new set of fragilities. Here. All right, so I'm only replacing F3D loss with elevated component. I'm interpolating 1D and I'm picking D1 and the second thing, D2, D3, up to D5. And I'm applying this for 20% of the building. And else, if the building is not archetype 1 and 3, do the same thing, except calculate the flood elevation from the versa floor elevation. And I will do this for all the number of buildings that I select. Like here, you will find the same thing, 30% and 40, 50, up to 70, and then we have 80, 90, and 100. So this is 100% of the building are applying flood barriers with elevating components, okay? Does any one of you have any question? Is that difficult? All right, okay. So I did this for just flood duration and elevating components. So let's do the same thing with flood barriers and elevating components. So you can come here. You'll find that I did the same thing. I'm naming another one, loss, elevating components coming from fragilities for HP1, height of barrier number 1, which is 0.2 meter. And I have high barrier 2, 3, 4, 5. And then I'm making a for loop to go building by building and calculate the base flood loss. So basically you will copy all the barrier, all your work on barriers, and just replacing this one. Look at this one. Loss, AC, fragility, HP1. And let's look at what we did last lecture. Here. It is the same thing. Same code, same everything, except I'm using different name. This one. I'm just adding AC after loss. That means I'm calculating the losses from fragilities that are mitigated with elevating water sensitive components. Okay. So let's get back. Yeah, here. So here I'm reading the shapefile, the everything, the verse floor, the verse floor elevation, the ground elevations, the building archetypes, the building values. So this is the main 4 components that we need. And I'm defining the losses for coming from the base flood losses. I'm defining a matrix for the base flood losses without any mitigation, and I'm calculating the losses with elevated components and also with barrier number 1 for 10% of the building. And I'm keep defining all the matrices and doing the same thing. If the flood depths measured from the ground elevation is less than the barrier height, so flood losses is 0. But if the flood depth is more than the barrier height, so calculate the flood losses. But right now, when you calculate the flood losses, don't use the regular fragilities or the regular loss surface. Use the loss surface that are coming from 3D surface with elevated components. And this is the one that I just showed to you in a minute. Don't use this and use the other one. This one is loss without elevated component, but this one is a loss with elevated component. Just to change it, what surface that I'm gonna use for interpolation by name here. It just has this. So this part is gonna ask MATLAB to use, rather than this surface, to use the other surface. And same thing, I'm gonna do it for barrier height number 2, for barrier height number 3, 4, and 5. And as I told you, we are not interested in how much is the new losses. We are interested in the loss reduction. So finally, after you are done with each step, you calculate the flood losses with elevated component and with each barrier name, how much reduction that you will have. That's why I'm subtracting the losses with mitigation from the losses without mitigation. It will give me how much this building is saving in losses. And then I sum all the losses from all the buildings to get how much total loss reduction that I have at the community level. All right, does anyone of you have any question till now? Okay, let's see how is the results will be look like here. Right, so I just want to confirm that we have 3 values of losses. A loss that comes from with mitigation, right? Loss without mitigation. So loss with mitigation and loss without mitigation, whatever this mitigation is, like if it's a barrier height, if it's bombs, if it's elevating water sensitive components, or all of them. So loss with mitigation, loss without mitigation. If we want to know how much loss reduction, we subtract the loss, we subtract both of them, like loss without mitigation minus loss without mitigation. So you get how much loss reduction for each building. And then we sum for all the building to get how much loss reduction at the community level, from building level to community level. I'm gonna show you the results and you tell me if this results at the community level or building level. So if you look at the y-axis, you will find that the value is 85 multiplied by 10.6 US dollar. That's been $85 million, the lowest value. Is that could be at the building level or at the community level? Community level, it's a big number, right? So right now, that's what I did. I didn't plot 80 values at the building level because I have hundreds of buildings, like 2,000. I cannot block all of them. So I'm blocking how much losses at the building level, at the community level that I have. Look at the barriers. On x-axis, I have 1, 2, 3, 4, 5. 1 is barrier number 1, HB1, HB2, HB3, 4, 5. Barrier number 1 is 0.2 meter, 4.4, 0.6, 0.8, 1. And what do you expect if you are using a more barrier height? Is the flood losses increase or decrease? Decrease. Decrease. The flood losses decrease, and so we have loss reduction more with more barrier height. And what is each one of these curves? Just
percentage of them that are using that mitigation.
yeah, the percentage of the population, because I have here each one of them 0, 10, 20, 40. Okay, so I have this one. What do you expect? What is this one? Is that 0 or 100? 0. That's 0. Like if no one is applying mitigation, so there's no reduction. But if 10% is applying mitigation, here's the reduction of the flood loss with this barrier. Can you see how much reduction that you have? With barrier height, like having, for example, 0.2, it's a very, very low. And if you use barrier height 0.4, 0.6, 0.8, 1. So you will see how much reduction that you have. But look at this gap. Here's the flood loss reduction is getting increased at like 20%, 30, 40, 50, 60. From 60 to 70, you have much more loss reduction when you move it from barrier height 2 to 3. Okay, from barrier height 0.4 to 0.6. So with all these mitigation measures, let's assume that we have 100% of the buildings are applying flood barriers, and all the barriers that were built is 1 meter height. Look how much loss reduction that you will have. Here we have $133 million in losses if there is no mitigation, but we can decrease the flood losses to be how much? It will be like 87 million. So we are moving from 133 to 87. It's like almost $40 million in loss reduction.
So in this procedure, did you include the cost of actually using that mitigation?
No, we have it in another publication, and we did also optimization. So this I'm not sure if we did it for elevating buildings, and we did it for building buyouts, but we didn't do with this. But it's worth investigation how much each barrier is gonna cost and if it's effective or not. So you will have another curve that shows you the cost and shows you what is the optimal percentage of people that should apply barriers or when to apply barriers. But everything is uncertain. How much hazard that you are gonna get and everything. So it's a little bit complicated, but it's also worth investigation. Okay, so we have this amount of flood loss reduction. We are talking about the losses is dropping from 133 million to 87 million just by using barriers. So let's see what will happen for flood duration, just the flood duration without any mitigation measures. Look at this. This is the mitigation scenario if we are using bombs to decrease the water duration. This is scenario 1, 2, 3, 4, 5. 1, if the flood duration is 10 days, if the flood duration is 8, 6, I believe this is 6 or 4. Let's check. Okay, so we have the duration. Okay, 10, 8, 6, 2, 1. All right. So, all right, so we have 10, 8, 6, 2, 1. Look at this. If the flood duration is at like 6, 8, 10, look how much loss reduction that you have. So if you get a bomb that is working for like 6 days and didn't dry the water out, so there is almost no loss reduction. But you will see huge amount of loss reduction once the flood, if you were able to dry out the water in 2 days. Look how much loss reduction that you will have. You are moving from $133 million to 100, maybe if all the people, like all the community, were able to dry out the water in 2 days. So the flood loss reduction is like 133. So we are like, we have like 10 million in loss reduction, which is way less. We are applying flood barrier because there's still water, there's still components that are going to be damaged. Okay, and if you were able to decrease the flood duration to 24 hours, like one day, you can decrease the flood losses maybe like $96 million. So we are moving from 133 to up like $35 million in flood loss reduction by just the bonds. Okay, so what is with elevated components? What if we were able to elevate components? Let's see this curve. Okay, can you guys explain to me why these curves like this when we have elevating components? Why? So you don't start at the same zero. Like all of them, like all the building up there, they are starting from the same point. But here, each one is starting from different point. You guys know? Right, let me explain.
Because there's no damage when you elevate the components at a certain.
Yeah, kind of like the same way they described, but here's the detailed explanation. So here is no one of all the building is elevating components. So we have the same base flood loss, 133 million. But if the flooding is hitting a building that has an elevated component, so you have immediate loss reduction, like you have an immediate loss reduction. So if 10% of the building has already elevated the components, so you will have immediate loss reduction. Not all of them are starting from zero. So this is without any elevation, but this with elevation. So this is right now we are talking a mitigation measure that happens before the flooding. You already mitigate your building. So it's like the flood. Let's assume we have a community here and we have a community there. These communities didn't elevate the components, and this community elevated the components. So not all of them is gonna expect to have the same damage, right? So that's what we are doing. I'm comparing a community without elevating components and another community that was hit with the same event was elevating components. Not all of them are gonna have the same losses, okay? All right, but still, if 10% of the people in this community elevated the components, so you will have this curve. If 20, 30, 40, 50, so not all of them are the same. If 100% of the community has elevated components, so basically you will start here. Your community have this losses just for the base without any mitigation measure, because elevating components start from here. Like I'm fixing elevating components at all these mitigation measure. I'm only saying I'm using pumps with elevating components. Like let's see here. What is the difference between the other mitigation measures and this one? At each scenario, you have 10 days, 8 days, but from scenario number 1, you have elevated components. From scenario number 2, you have so it's a fixed thing, all right? Okay, so this one is like this one. Like pumps is the same like this one, but I just elevated the components. So elevating the components makes you to start at the lower base. And you will see that the flood loss will be like around like $78 million. So we have this reduction, but if you only using pumps, it will be like around like 95, $96 million. I did the same thing with flood barriers. So this one is like this one, but I just added elevated components. So basically they will be dispersed. But you will see, okay, but this one is different than this one, because I believe I use different intervals. Like this is 130, 120, but here is 120, 125. So, and here it starts, I believe, from $70 million. So they are a little bit different. This one and this one. This start from 70 and keep increasing 70, 80, 90. Here's 85, 90, 95. But this one is the same exactly like this one, except that we having elevated components. So each one has different loss level. Does any of you have any question on these curves? These curves are very important. These curves can help in mitigation planning, so you can have but what helps more is to show cost. each one of these. So that will help more, like to know, is it efficient to spend money on these resources to do this mitigations or not? Okay, so the next one, the next mitigation measure, and I believe I don't want you to do this, but I will just explain it if you want to do it. So I only want you to do for this project, this four, like flood barriers, flood duration with elevated components, and flood barriers with elevated components. So the next one that I don't want you to do it, but if you do it, that will be great. What if you did barriers with flood duration? What if you investigate it using pumps and using barriers? Sometimes, actually, when I did this, I was like, can anybody do that? Like he built a barrier and the bump and all of this. What do you think? Is that, can people do it? Like to build like maybe a flood barrier and also in the same time you have a bump and you have all of this? When I searched, I was surprised. There was people doing that. Like, I actually put a picture here, I believe. Not sure if I put a picture here or not. Let me search on Google. One barrier. Let's go to images. I believe I saw it somewhere. There was like many pictures that people have flood barriers around their buildings and they pump the water out. I believe this is one of the pictures that you have a barrier here and you have pumps that takes the water from a place to another. And this is, I believe, maybe one here. There was many of them when I was searching, and actually, yeah, something like this, but this is, yeah, there was like many pictures that I saw flood barriers. Check this second. So this was like one of the barriers, and there's a bump here, but there's many examples that you can use. Like here, this is a water pump and there was a barrier. So there's many examples that you can use both. So if you want to do this, you can do this. Like you will see here, how did I do it in MATLAB? This one is, okay, elevating components with barrier height. Okay. All right, so this one is using flood barriers and bombs to decrease flood duration. Okay, so I'm doing for 10% of the building, and then I defined losses coming from fragilities for barrier height #1 and flood duration D5. So you can do many combination of mitigation measures. You will find that you can, not this one. Here, you have barrier height 0.2 meter and you have 5 duration. So you can try this barrier 0.2 meter with all these flood duration number 10 days, 8 days, up to 1 days. Or you do a barrier height HP2 with 10, 8, 6, 2, 1. But I didn't do that. What I did, I just picked HP1 with D1, HP2 with D2, HP3 with D3. So I only picked these values. But you can try it with any other value. And here, so I define HP1 was D5, HP2 was D4, HP3 was D3, and I did all of these. and this is for only 10% of the buildings. And what I did here, I calculated for building archetype number 1 and number 3, I calculate the base flood losses for the 10% of the building. And then I said if the flood depths measured from the ground elevation is less than barrier HB1, so there is no need to do any loss mitigation analysis. I just put the losses as 0 because the water didn't exceed the barrier height. So there is no need to do any interpolation. But if it's exceeded, the loss value using barrier height number 1 for duration number 5, interpolate from the 3D surface and using the flood depths at D5. So what I did exactly, I calculated the flood loss at the D5. So I went to the surface at D5 and calculated the losses. If you remember what we did with the just the flood barriers, we interpolated at a specific duration for all the buildings. But right now, we can change the duration. We can change the duration to 10 days, to 6 days, to 4 days, or to 1 day, right? So that's what I did here. Once I'm done, I did another one with barrier number 2 and D4. So here I interpolated at D4. You will find that I tried another one with D3, and I tried another one with D2 and D1. Yeah, here is D1. So if you look up there, what we did here, you will find that all of them were D5. All of them, D5. We didn't change the flood duration because we fixed the duration to be the maximum duration and calculated the flood loss that only with flood barrier mitigation. But what we did next is to combine duration and barrier. So we kept it changing the duration. D5, like if it's 10 days, 8 days, 4, 2, and 1 day. That's what I did down here. Yeah, HP with D here. And let me show you the losses when we combine all of these together. So this one is flood barriers and bumps. Here's as you can show, it's just like combining these two together. This one and this one, but in different ways. Yeah, so can you see here how much loss reduction that we are gonna have from 133 million to almost $60 million. So we are reducing the flood losses by more than 50%. So about like $73 million in flood loss reduction, which is huge. What if we applied all of them together? What if we use the flood barriers with pumps and also with elevating components? So you will use the elevated water sensitive components, and also in the same time, you will use pumps and you will use flood barriers. I found out that we can decrease the amount of flood loss reduction to $50 million. So you are moving from 133 million to 50 million. So it's about 83 million loss reduction. So I'm just giving you an overview on the different ways that we can do for mitigation loss analysis. Does any of you have any questions? You are not required to do these two. Just the other barriers and what else? Barriers, bumps, and bumps with elevating components, and flood barriers with elevating components. You are not required to do this too. All right, so you guys have any question, anything in the coding, and stuff like this? I'm just like, it's the same thing. Like, it's repetitive. You will only, like, if you did it once for 10% of the buildings, you just copy paste and replace the 10% by 20. It's the same code. You'll find it's thousands of lines, like here. But it's not as it looks so. Why? Because it's the same code. Like each 200 codes, you just write maybe a 50 line. But the same 50 line are repeated 10 times. Same thing. You will just find and replace and change something. okay? And it will end up as like the 50 becomes 1,000, yeah, or the 75 becomes 1,000, right? So this is the same thing, like if you apply for duration, for barriers, so you'll find out if you just do it for only 10% of the building, it's not like these will be like 500 lines or something. But I want you to copy paste it 10 times and run the code. It doesn't take that much effort. It's just like maybe it will take an hour more, but you will get a huge amount of data that can show you the spectrum of mitigation that you can apply for the community and how much that you can do for the community. And we are interested only in one number, the community level flood loss reduction, which is, you will find it here in the code. This number. Let me get back there. If you look at the early verse mitigation that we did here, we are interested in this number. Loss reduction with barrier height HB1. This one will give you how much loss reduction at the community level, because this is the number that I plotted here. And as far as I remember, I put all these numbers in tables, like, okay, look here. I wrote a code that put all these in a table. Loss R, total S10. Let's look at these. By the way, do you guys know what is on the right side here? When you have MATLAB, you will find something called workspace. Anything that you do here, it's stored here in metrics. Okay, so let's look for these metrics. This metrics has the loss reduction total for 10% of the building coming from. So what I did, let me just double check because it looks like I did something to ease. This is S20. Okay. Loss reduction total. Yeah, here. So loss reduction total for S10. Let's look at these. This one is stored here. If I open this, it has 5 numbers. What is these numbers? This is one. Actually, yeah. So here it looks like you have 140K, or this is, yeah, 140K, 760, 1.6 million, 3.2 million, 4.9 million. What is these numbers? These are the number if 10% like 200 buildings, which is very few amount of buildings that do mitigation measures. That's why this number is very, very low. Like how much loss reduction at the community level if 10% of the building is applying flood barriers. And the first number is the flood barrier, which is number 1. This one is if for flood barrier number 1, 2, 3, 4, 5. 1 is 0.2 meter, 0.4, 0.6 up to 1 meter. That's why this number is getting increased. So I usually, it's better to tabulate this data. Like, let me show you some tables. Maybe I saved the table somewhere else. But anyway, you can take these numbers in a table out and tabulate them so that you can facilitate plotting them. When you plot them, how it will look like. Like if you look at if 100% of the building are applying this, can you see the numbers are getting increased? 800K, 3.9 million, 1.39 million. Sorry, it's 13 million, 27 million, 46 million. This is the loss, just the loss reduction. How much the loss reduction will be look like if 100% of the building are applying flood barrier. So you can take these numbers out and you take them to Excel and plot them in Excel and make plots like the one that I did here in this publication. Actually, I did this in MATLAB. So you can either plotting them in Excel or plotting them in MATLAB and see how they will look like. Let me just double check and see where I saved this data to be plotted. Just like to show you an example. flood duration. Not sure where did I save, because I remember when I did all these mitigation measures, I put them in Excel file. So for example, I have mitigation that are coming for different barrier heights, for different numbers of percentage of buildings applying these barriers. So you'll have like X and Y. So that's why what is the best way to do it? You have on the X-axis, for example, the percentage of the buildings, and on the Y-axis, the barrier height, and then you can plot them. You can plot them in a 3D surface because you can plot a surface, but I saw it's better to have them in this format. So if you plot, I actually tried to plot these as a surface, and these are the steps of the surface. Like it will show you something that starts this and it goes down like this. But what I did, rather than having a surface, I just have them as a separate curves plotted on the same 2D curve. Yeah, anyway, I will search for the plotting. Maybe it can help you. I can send it to you, or I can show it to you next time and see how if you want to plot these. All right, so I believe we are done with mitigation at the building level, like doing things for buildings. Next time, I'm gonna show you how to investigate mitigation at the community level. What if you build a levee or build a temporary barrier system or build a retention system to absorb the water? So we are decreasing the hazard, and see how this is gonna impact the amount of flood loss reduction. Does any of you have any question? Is it difficult?